Alright, well hello 8th graders. Welcome to this video, which is meant to introduce you to this idea of work. Now obviously we've all used the term work before, but it has a very specific meaning and definition when we're talking about energy and in the physics realm. So work is very simply an energy transfer between a system and its surroundings. So up to this point, when we've been dealing with conservation of energy, we've said that within a system, that amount of energy cannot change. However, if we have what we call external forces acting on a system, energy can be transferred into or out of that system. If we go back to the bank analogy, you can think of work like getting paid or having to pay a bill, where you could have money coming in or money going out. With work, if we have external forces acting on that system, we could have energy flowing in or we could have energy flowing out. So I'll just draw a little blob here. So let's say that I have a system of objects. I could have energy flowing in. We would say that that's positive work because it's adding energy to the system. We can call it an energy input, I suppose. Or we could have energy flowing out. So we could say that this is an output and this is an input. Now if energy flows out of our system, we would say that that's negative work. Okay, because that force that's being applied is actually causing energy to leave the system, meaning that negative work is being done. Now, there could be an external force that acts on a system that actually does no work. And that's kind of a special case. So we can have situations where we have zero work being done. For that to happen, that force would have to not cause a change in that system. So, for example, let's say that I lean up against a wall. Well, I'm applying a force to that wall. I'm pushing up against that wall, but the wall is not moving. That system didn't change. So in that case, there is zero work being done. So the key for us when it comes to identifying which type of work is being done, is it positive, is it negative, is it zero, we have to ask ourselves what change is occurring for that system or for that object. If that object is gaining energy, we know that positive work is being done. Energy is being input. If that object loses energy or that system loses energy, we know negative work is being done. If that system doesn't change because of some force that's applied, we know that zero work has been done. So again, just to be clear, zero work would mean that the energy within that system doesn't change. So zero work, energy in system does not change. There is no transfer of energy either in or out of that system. All right, so to give you a sense of how we can apply this idea of work and how we can relate it to energy, we're going to work with some LOL diagrams here. So scenario one here, we've seen this. We've seen this scenario before. We have this crate pushed up against this spring, and then it's shot off, and this is our final snapshot where this crate is now at some height and it's moving. Now, before, we would identify the objects in our system to be the spring, the crate, and the earth. Well, what I'm going to do now, just so you can see how work can actually transfer energy into the system, I'm going to just say that now only the crate and the earth are in my system. That means the spring is outside of the system. The spring is still compressed, but what does that mean for us initially now? If only the crate and the earth are in my system, I have no energy initially. There's no energy initially. But finally, I end up with some amount of KE, and I end up with some amount of gravitational potential. Because again, this crate is moving and it's at some height. So where did this energy come from? It came from the spring. The spring applied a force to this system, namely the crate, to give this system energy. So this spring transferred its elastic potential energy into the crate. So how we can show this on our energy flow diagram, this is where this really becomes important. We're showing that energy is flowing into this system because of the work done by the spring. So now if we want to write a conservation of energy equation, well, we have no energy initially, but we have work done by the spring. And then that's going to equal the stuff that I have final. So I have KE final plus PEG final. All right, now this beautifully hand-drawn second scenario here. Our initial snapshot, I have this block and it's moving to the right at some velocity. The final snapshot, it pushes up against the spring and it's momentarily, for that split second in time, it's momentarily at rest. So again, what I'm going to do here, I'm going to say that my system just consists of the block and the earth. Well, initially, in this system of the block and the earth, I have kinetic energy because this block is moving. So I'm going to say that I have all KE. But now finally, the block's no longer moving and the spring is not in our system. So finally, I have no energy present in that system. Where did the energy go? The energy flowed out of the system because of work done by the spring. This spring applied a force to this block, to this system, to cause that system to transfer energy out. So our conservation of energy equation then, we would have KE initial minus, because this is negative work. If energy flows out, it's negative work, minus work done by the spring equals, there's nothing here, equals 0. Okay, so big takeaways from this video. Work is an energy transfer from a system to its surroundings caused by forces that are external to that system. In both of these cases, the external forces came from these springs. In this case, energy flowed into the system. In this case, energy flowed out. So you just saw an example of positive work, and you saw an example of negative work. If you have any questions about this, please let me know. Otherwise, take care.